welcome to the first part of the onboarding series for V-Ray for Grasshopper. This series is dedicated to demonstrating how you can visualize your algorithmic designs without ever leaving Rhino's powerful parametric modeling software. In this introduction video, you'll get a brief overview of the basics, how to set up and render a Grasshopper definition in V-Ray. Installing V-Ray for Rhino comes with a direct integration of Grasshopper. The V-Ray tab is divided into 5 panels. The first panel contains components regarding geometry creation. Let's create a V-Ray geometry, also known as the VGeo component. This essential component transforms your Grasshopper mesh or geometry into a V-Ray geometry that can be used by the renderer. Next is the lighting panel, with different lights and light rigs. The Materials panel contains components for bitmap, different materials, and material loaders. The Render panel contains components for rendering, camera, and animation. For now, let's create the Render component. This important component compiles all the elements that build the scene and controls the render settings. The last panel contains render elements for denoising and lighting analysis. Every V-Ray component has its own context menu with different options, but most of them have Show Controls, an option that extracts input nodes for faster visual setup. Rendering could be performed on CPU or GPU. If you have an NVIDIA RTX card, you can pick that engine. Next, choose Interactive or Production mode. While we are working on our model, it's best to stick with interactive mode, as it will give us a better preview of the changes we make, because it refines the whole image with each sequential pass. For our production renderings, we can use either bucket or progressive rendering. The quality of the final image is also preset-based. Keep in mind that a higher quality preset will mean your computer has to spend more time calculating the image. In addition, it is good to create and connect a V-Ray denoiser component before initializing the render process. It applies a denoising operation for smoother image output without sacrificing the render time too much. Since I'm already rendering on the GPU, it's best to leave denoising to the CPU and switch to Intel's Open Image Denoiser. For the final image, it's best to use V-Ray's proprietary denoiser, as it is the most accurate for high-quality renders. Typing V-Ray in the component search window will give you a list of all V-Ray components. Detailed information on each component function can easily be found from the Help menu. To start rendering, right-click over the component to display its context menu and click Render. The V-Ray Frame Buffer, abbreviated VFB, will appear. This is a powerful image viewer that you can use for quick color corrections and many post-production effects. The VFB is currently empty because the Grasshopper definition has to be connected via VGeo to the Render component. We render with RTX GPU engine in interactive mode, without baking the definition. This means that the definition is live and editable. By default, each VGeo has a generic gray material applied. You don't need to set material if you don't need it. If you want another visual representation, the V-Ray material preset or MTL preset can be used. Set the preferred color and choose from the available presets. Organize your geometry and corresponding materials to your taste. In the same way that VGeo has an assigned material by default, the V-Ray render component has an image-based lighting assigned by default. Additional V-Ray light or light rig components can be created and connected to the respective input of the V-Ray render component. An easy way to orientate the rig symbol is by using the slider component. Next, let's create a camera. To lock the view while navigating and expose additional options, connect the V-Ray camera to the render component. The context menu allows the new camera to adopt the Rhino viewport or any standard and named views in your Rhino project. 2 additional renderers can be launched from the V-Ray LiveLink component. To evaluate them and send the scene to another render engine, connect the scene output with the corresponding input in the LiveLink component. The first option is a real-time rasterizer called V-Ray Vision. Vision comes with the V-Ray for Rhino installation and starts up in its own window. The navigation is available from the Rhino viewport or from the Vision window as well. Every change that you make to your definition is live and is updated on the go. That way, you don't need to bake your geometry to see a rendered result, and your workflow stays more efficient. The second option is Chaos Vantage, a powerful RTX GPU-based real-time ray tracer. Chaos Vantage is a separate product with a standalone installation. It uses a different port for live scene data and has its independent UI. As with Vision, the definition can be navigated from the Rhino viewport as well as from the Vantage viewport. All updates are happening in fully traced real-time, perfect for iterative design. Thank you for watching this video. We hope you have a better understanding of the basics of how V-Ray for Grasshopper works. In the next onboarding videos, we'll go over adding additional geometries, setting up lighting, materials, cameras, as well as rendering stills and animations. See you there!